Hello students, now we are going to see gate delays and timing diagram and simulation and testing of logic circuits from third module. Okay. Gate delays. So for a gate we have input and output. For different types of input combination we will get different types of outputs. Okay. Whenever the input changes, the output will not change immediately. Okay. The gate take finite time to react to a change in input, so that the change in gate output is delayed with respect to the change in input gate. So that only we are going to see. We have taken one NOT gate. Vi is the input, v naught is the output. Okay, so we'll see the timing diagram also. Vi is initially 0, then it changed from 0 to 1, again it changed from 1 to 0. Okay, how the output changes for the changes in input, we'll see that. So initially we know that if input is 0, output will be 1. If input is 1, output will be 0. This is for NOT gate. Okay, Vi is initially 0. So if Vi is 0, V naught will be 1. This is 0, this is 1. Okay, now Vi is changed from 0 to 1. But you can see actually in this location it must be changed to 0, but it is not changing. Output is not changing. Output is taking some finite time to react for the change in input. So this is called delay. Okay, so there is two types. There are two types of delay. From 0 to 1, different type. 1 to 0, different type. Okay, if the change in the output is delayed by time epsilon with respect to the input, then we can say there is a propagation delay of epsilon. Okay, and as I said, propagation delay for 0 to 1 and 1 to 0 both are different. Okay, but in many circuits this delay is neglected, but in some cases, some sensitive circuits, this also considerable. Okay, so this will affect the circuit output. Okay, so this need to be eliminated. One more example we can see. There are two gates. One is AND gate, another one is OR gate. AND gate inputs are A and B. OR gate inputs are G1 and C. Okay, we'll see the timing diagram. First one is A. A is taken as 0. So A is 0 means the AND gate output G1 can be 0 and 1. This is 0, no? So 0 and 1. G1 equal to 0. G1 is equal to 0. Now A1 is changed from 0 to 1. Now A1 is 1. Now 1 and 1. G naught should be 1 and 1, 1. Okay, see in this location it changed from 0 to 1. Okay, so the G1 also must be changed from 0 to 1. It also must be changed from 0 to 1, but it is not changing. It is taking some time. So here 20 nanosecond is the delay time of AND gate. This is the delay. Okay, now how the G1 affects G2, how the output 1 affects the final output of the circuit. Okay, so this is intermediate output. How it is affecting the G2, we'll see. G2 is 0 here. Till this it is 0. Okay, so G2 is 0. C is also 0. 0 plus 0, 0. Inverter is there. So G2 output is 1. So G2 1 we got. Okay, now see G1 changed from 0 to 1. G1 is 1. So 1 and 0. 1 plus 0, 1. Inverter 0. So G2 should be 0. Where? Here. At this point it must be changed from 1 to 0, but it is not changing. Till here it is not changing. So this is the delay time of OR gate. OR gate delay is also taken as 20 nanosecond. Okay, so this is here also again delay. So whenever the change is happening in input side, that is also affecting the output. So this will be the problem in few sequential circuit. Okay. Next, simulation and testing of logic circuit. Once the circuit is ready, once the logic circuit is ready, that design must be tested and debugged. For that, we can use two ways are there to test the circuit. We can really make the circuit and test that in real time, or you can go for the simulation. But in these out of these two options, simulation is the best option because it takes less time. It takes less time and cost also less, and it will give the accurate output. So we always choose simulation for the debugging of logic circuits. Okay. And there are many advantages also. That's what I told. The verification that design is logically correct, and timing signal, it gives exact timing signal, and simulation of faulty components in the circuit as an aid to finding test for the circuit. Now when we are using a computer or means a software for simulating the logic circuit, first we have to specify the circuit components and connections, then we have to specify which are the input, then finally we can check the output. Okay, that's what a simple simulator for a combination logic circuit works as follows. First, what we have to do, you can see here. First, the inputs for digital circuits, the inputs can be 0 or 1. So the first, digital inputs can be given to the first level gates. This is the first level gates. So inputs are given to first level gates. Then the first level gate will produce the output. Okay. Then if there is any changes, in the input, again the first level gate will be updated. This will happen till there is no further change in the input. Okay. Then this output will be given to the second stage gate. So this is the input of the second level gate. Okay. So in that case, this gate are called steady state. These gates are called steady state gates. Okay. So that time that output will be given to the stage 2 gates, then that output will be calculated. Okay. This is the simulation screenshot switches. You can see in the first stage there are 2 AND gates. In the second stage we have only one AND OR gate. Okay, the first AND gate inputs are 1 and 0. So 1 into 0 you will get 0. 1 and 1 second gate inputs, the output is 1. So now these two are the input for the OR gate. 0 and 1 are the input of OR gate. So 0 plus 1 output is 1. One more. First AND gate inputs are 1 and 0. So 1 into 0, 0 is the output. Second gate inputs are 1 and Z. 1 and Z. So the output is, don't care, it can be 0 or 1, we don't know that. Now the inputs for OR gate is 0 and X. So the output is X. The output can be 0 or 1. Okay. Thank you.